Unit 13 Chemical Bonding. In this unit, we will study about Kossel-Lewis approach to chemical bond, Lewis dot structure and different types of reactions. Come, let's get into this video session.
Hello children, today we are going to start 9th Standard Science Unit 13 Chemical Bonding. Learning Objectives: to understand how molecules are formed and what is a chemical bond. To explain octet rule. Here octet rule means the outermost shell contains 8 electrons. Draw Lewis dot structure of atoms. Then, to understand different types of bonds. Then, differentiate the characteristics of ionic bond, covalent bond and coordinate bond. Understand redox reactions. Redox means oxidation and reduction takes place simultaneously. And find out the oxidation number of different elements. How to define chemical bonding? For example, flowers are held together by a thread. In the same way, atoms are bind together by a bond. That bond in between the atoms, that is force of attraction. So, what is chemical bond? A chemical bond may be defined as the force of attraction between the atoms that binds them together as a unit called molecule. In this unit, we will study about Kossel-Lewis approach to chemical bonds, Lewis dot structure and different types of reactions. Kossel-Lewis approach to chemical bonds. Atoms of various elements combine together in different ways to form chemical compounds. Kossel and Lewis gave successful explanation based upon the concept of electronic configuration of noble gases. Here noble gases means helium, neon, argon, krypton, xenon and radon. These are, will say, noble gases. About why atoms combine to form molecules. Atoms of noble gases have little or no tendency to combine with each other or with atoms of other elements. This means that these atoms must be having stable electronic configurations. Here we have the electronic configuration of noble gases. Here first is name of the element helium. Its atomic number is 2. Electronic configuration is 2. 2 means the outermost shell in the helium atom is completely filled. Okay. Next is neon. Neon atomic number is 10. The outermost shell of the neon atom is 8. So it is also completely filled. Next is argon. Argon atomic number is 18. The outermost shell electrons are 8. Krypton atomic number is 36. The outermost shell, fourth shell of electron is 8. Xenon totally atomic number is 54. Outermost shell is what completely filled, that is 8. Next is radon. Radon atomic number is 86. The outermost shell valency electrons is what 8. So these all what noble gases and stable. Why? Because in the outermost shell electrons is completely filled. So these all will say noble gases. Except helium, all other noble gases have 8 electrons in their valency shell. Even helium has its valency shell completely filled and hence no more electrons added. Thus, by having stable valency shell electronic configuration, the noble gas atoms neither have any tendency to gain nor to lose electrons, hence their valence is zero. So, Kossel and Lewis proposed a theory in the year 1916 to explain chemical combination between atoms, and this theory is known as electronic theory of valency or octet rule. Why it is called octet rule means it should be a sharing or transferring electrons in the outermost shell must contains 8 electrons. So, the tendency of atoms to have 8 electrons in the valence shell is known as the octet rule or the rule of 8. For example, sodium with atomic number 11, its electronic configuration 2, 8, 1 will readily lose one electron to attain neon stable electronic configuration. Yes, now come to this picture, how the formation of sodium ion. In the first shell, totally 2 electron contains. In the second shell, contains 8 electrons. In the outermost shell, only 1 electrons in the sodium atom. Na means sodium. Okay, so this outermost shell 1 electrons is ready to lose electron and forming as a what? Sodium ion or cation. So this is the formation of sodium ion from the sodium atom. So now the sodium ion electronic configuration is in the first shell 2 electrons, in the second shell, outermost shell, how many electrons? 8 electrons. Chlorine has electronic configuration 2, 8, 7. Its atomic number is 17. To get the nearest noble gas, example argon configuration, it need one more electron. So, chlorine readily gains one electron from other atom and obtains stable electronic configuration. Now come to the picture. In the chlorine atom, in the first shell 2 electrons, in the second shell contains 8 electrons, in the outermost shell 7 electrons. So they need 1 electrons from the other atoms. So they gains 1 electrons from the other atom and forming as a what? Chloride ion. So it gains 1 electrons from the other atom and form as a what? Chloride ion or anion. So now in the chloride ion, in the first shell contains 2 electrons, second shell 8, in the outermost shell also 8. This is called octet rule. Now come to the tabulation of unstable electronic configuration. Element boron, its atomic number 5, electron distribution is 2, 3. In the valence shell, electrons is 3. It loses 3 electron to other atoms, then only it become a what? Unstable electronic configuration. Next element is nitrogen, its atomic number 7, electron distribution is 2, 5. So it needs 3 electrons to become a what? Stable electronic configuration. So this is also a unstable electronic configuration. Next is oxygen. Its atomic number is 8. Its electronic distribution 2, 6. So in the valency, electrons is what? 6. It needs 2 more electrons to become a what? Stable. So this is also a unstable electronic configuration. And next is sodium. Its atomic number 11. Electron distribution is 2, 8, 1. So it has an excess of 1 electron, so it is ready to lose electrons and become a what? Stable electronic configuration. So these all the elements are unstable. Electronic configuration. Lewis dot structure. The Lewis dot structure or electron dot symbol for an atom consists of the symbol of the element surrounded by dots representing the electrons of the valency shell of the atom. The unpaired electron in the valency shell is represented by a single dot, whereas the paired electrons are represented by a pair of dots. Symbols other than dots, like crosses or circles, may be used to differentiate the electrons of the different atoms in the molecule. Lewis dot structure. Hydrogen element, its atomic number is 1, its electron distribution is 1, valency electrons 1, its Lewis dot structure is hydrogen H. Here unpaired electron means we will give a what? Single dot. Okay. So hydrogen has unpaired electrons, so we'll give a single dot. Helium atomic number is 2, electron distribution 1, valency electrons 2. Here we have a paired electron, so we'll give a paired dot. Next, beryllium 4, atomic number, its electron distribution 2, 2, valency electron is 2, and beryllium has a what? Unpaired electrons, so we'll give a unpaired dot. It means single dot. Next is carbon. Here atomic number is 6, electron distribution is 2, 4, valency electron is 4. Here also we have a unpaired electron, so we'll represent this unpaired electrons represented by a single dot. So nitrogen atomic number is 7, electron distribution 2, 5, its valency electrons 5. Here in the nitrogen, listen carefully, 2 paired electron is there, so that will keep 2 paired dot, and after 3, that is what? 3 unpaired electrons, so that will these 3 electrons represented by a what? Single dot. Okay, 2 dot is a paired electron, so that paired dot, and other 3 is a what? Unpaired electron, so that what? Single dot. Next is oxygen, atomic number is 8, electron distribution 2, 6, valency electron 6. Here we have a what? 3 paired dot. It means 3 paired electrons is there, so that these 3 paired electrons represented by a 3 paired dot. So totally 6 dot is there. Let's see the types of chemical bond. This chemical bonding are classified into two bond, that is strong bond, weak bond. The strong bond are classified into ionic bond, covalent bond, coordinate bond, metallic bond. This weak bond are classified into hydrogen bond, van der Waals interaction. In these types, we are going to study about ionic bond, covalent bond, coordinate bond. Other all the types we will study in the higher classes. Depending on the type of bond, they show different characteristics or properties. Ionic or electrovalent bond. An ionic bond is a chemical bond formed by the electrostatic attraction between positive and negative ions, plus charge and minus charge. The bond is formed between two atoms when one or more electrons are transferred from the valency shell of one atom to the valency shell of other atom. Here valency shell, it is the outermost shell. Okay. The atom that loses electrons will form a cation, that is positive ion, and the atom that gains electrons will form an anion, that is negative ion. These oppositely charged ions, that is positive and negative ions, come close together due to electrostatic force of attraction. Okay, why it is come close together? Because of force of attraction, and thus form a ionic bond. As the bond is between the ions, it is called ionic bond, and the attraction forces being electrostatic. The bond is also called what? Electrostatic bond. Since the valency concept has been explained in the terms of electrons, it is also called as electrovalent bond. Now come to the formation of ionic bond. Let us consider two atoms A and B. Let's see the picture. Let atom A has one electron in excess and atom B has one electron lesser than the stable octet electronic configuration. You know that octet rule means in the outermost shell how many electrons should be there? 8 electrons. That is called what? Octet rule. So atom B needs one more electrons to complete the stable electronic configuration. Atom A have excess electrons. Okay, so if atom A transfer one electron to atom B, then both the atoms will acquire what? Stable octet electronic configuration. As a result of this electron transfer, atom A will become positive ion, that is cation. Okay, if any atom is transfer electrons to one another atom, it becomes what? Positive ion or cation. An atom B will become negative ion, anion. Why atom B is become negative ion? Because it gains the electrons. Okay, these oppositely charged ions are held together by electrostatic force of attraction, which is called ionic bond or electrovalent bond. Okay, you know that in between A and B there is a what? Force of attraction. Okay, this force of attraction called what? Electrovalent bond. Now come to the formation of ionic bond in sodium chloride. Let's see the sodium atom. Its electronic configuration is 2, 8, 1. Okay, in the first shell 2 electrons is there, in the second shell 8, in the outermost shell 1 electrons. So it is readily to lose electrons to the other atoms. Now come to the chlorine atom. 2 electrons in the first shell, second shell 8 electrons, in the outermost shell 7 electrons. So it needs 1 electrons to complete the octet rule stable electronic configuration. So when these two atoms come together because of force of attraction, this sodium form as a what? Sodium cation. Why? Because it has one electrons in the outermost shell to transfer other atom. So after transferring one electrons to other atom, this sodium atom form as a what? Cation. That is sodium cation. Next, chlorine atom needs of 1 electrons to complete stable electronic configuration. So it gains of 1 electron from the sodium atom and it forms as a what? Chloride anion, that is negative ion. Okay, when an atom of sodium combines with an atom of chlorine, an electron is transferred from sodium atom to chlorine atom, forming sodium chloride molecules. Thus, both the atoms attain stable octet electronic configuration. Now we'll come to the formation of ionic bond in magnesium chloride, MgCl2. The atomic number of magnesium is 12 and the electronic configuration is 2, 8, 2. It has two electron access to the nearest stable electronic configuration of a noble gas neon. So, magnesium has a tendency to lose two electrons from its outermost shell and acquires a stable electronic configuration forming magnesium cation, that is Mg2 plus. As explained earlier, two chlorine atoms will gain two electrons lost by the magnesium atom forming magnesium chloride molecule MgCl2. Magnesium symbol is Mg. Chlorine. Okay, chlorine atom is what? Cl2. So magnesium atom have excess two electrons in the outermost shell. So one electron is transferred to the one chlorine atom and another one electron is transferred to the other chlorine atom. And these chlorine atom needs a one electrons. Okay, first chlorine atom needs a one electrons. Second chlorine atom needs a one electrons to attain a stable electronic configuration. So this magnesium ion gives two electrons to the chlorine atoms and forming as a what? Magnesium cation, that is Mg2 plus. Why? Because it gives two electrons. One electrons to the chlorine atom, another one electrons to the another chlorine atom. So Mg2 plus, it form as a magnesium cation. In the chlorine atom, it needs a one electron, so it receives a one electrons from the magnesium atom and it is formed as a what? Chloride anion. So Cl minus, Cl minus. Now the electronic configuration of magnesium cation is 2, 8 and chloride anion is 2, 8, 8. Now we'll see the characteristics of ionic compounds. First, physical state. Ionic compounds are solid at room temperature. Next is electrical conductivity. In molten state, it only conduct electricity. Next is melting point. Ionic compounds have high melting and boiling point. Then solubility. Solubility. Ionic compounds are soluble in polar solvents like water. Okay, polar solvent means it's a water. And it is insoluble in non-polar solvents like benzene C6H6, carbon tetrachloride CCl4. Okay, so ionic compounds are soluble in polar solvents like water and insoluble in non-polar solvents like benzene, carbon tetrachloride. Density, oddness and brittleness. Ionic compounds have high density and highly brittle. Highly brittle means easily breakable. Reactions. Ionic compounds undergo ionic reactions which are practically rapid and instantaneous. Rapid means very fast. These are the characteristics of ionic compounds. Now we'll move to the covalent bond. According to Lewis' concept, when two atoms form a covalent bond between them, each of the atoms attains the stable electronic configuration of the nearest noble gas. Already we know that noble gas helium, argon, neon, xenon, these are noble gases. Since the covalent bond is formed because of the sharing of electrons which become common to both the atoms, it is also called as atomic bond. Why we are saying it is the covalent bond means in between the two atoms it is sharing of what? Electrons, mutual sharing. So this is also called as atomic bond. Now come to the formation of covalent bond. Let us consider two atoms A and B. Atom A has 1 valency electron and atom B has 7 valency electrons. As these atoms approach nearer to each other, each atom contributes, it means sharing one electron, and the resulting electron pair fills the outer shell of both the atoms. Thus, both the atoms acquire a completely filled valency shell electronic configuration, which leads to stability. So, in this picture, A atoms sharing one electrons and B also sharing one electrons, and here shared electron pair. So these pair is called what? Covalent bond. Okay, when this A sharing one electrons, B sharing one electrons, here they make a what? Electron pair. This pair is called what? Covalent bond. So here A and B attains a stable electronic configuration. Covalent bonds are of three types. One is single bond, another one is double bond, and triple covalent bond. In the single covalent bond represented by a line, single line between the two atoms, for example, hydrogen atom. In between the two hydrogen atom there is a what? Single covalent bond, that is represented by a line, single line. Double covalent bond represented by a double line between the two atoms, for example oxygen molecule O2. So there is a in between the oxygen atoms double covalent bond. So it is represented by a double line. Next is triple covalent bond represented by a triple line between the two atoms, that is nitrogen atom. In between the two nitrogen atoms there is a what? Triple covalent bond, that is represented by a triple line. Now we'll come to the formation of hydrogen molecule H2. Hydrogen molecule is formed by two hydrogen atoms. While forming the molecule, both hydrogen atoms contribute one electron each to the shared pair, and both atoms acquire stable and completely filled electronic configuration. Here in the figure, hydrogen atom, it has only one electrons in the outermost shell. So it needs a one more electrons to complete the stable electronic configuration. In the second hydrogen atom, it also needs one electrons to complete the stable electronic configuration. So these two atoms, both the electrons sharing, and it, it completes a what? Stable electronic configuration. So hydrogen atom, first hydrogen atom shares one electron and second hydrogen atom shares one electrons, and this shared pair electrons, it is called what? Covalent bond. And these two atoms while sharing, it forms a what molecule? Hydrogen molecule. Pair means there we have two electrons. Okay, in one pair we have two electrons. Next formation is that chlorine molecule Cl2. Here chlorine molecule is formed by two chlorine atoms. Each chlorine atom has 7 valency electrons. So 2, 8, 7. These two atoms achieve a stable completely filled electronic configuration octet by sharing a pair of electrons. Let's see this picture. In this first picture, chlorine atom in the outermost shell totally 7 electrons. It needs a one more electrons to complete the stable electronic configuration. In the second chlorine atom, it also has a 7 electrons in the outermost shell. So it also needs one more electrons to complete the octet rule. So these two electrons combining together and sharing one electrons, and it completes the stable electronic configuration. So First chlorine atom shared 1 electrons and the second chlorine atom sharing 1 electrons. Combining together, this makes a pair of electrons, and when combining these two atoms, it is a what? Chlorine molecule. Okay, so now this chlorine molecules is completed what? Stable electronic configuration. This is called the formation of covalent bond in Cl2 molecule. Next illustration is the formation of methane molecule, that is CH4. Methane molecule is formed by the combination of one carbon and four hydrogen atoms. The carbon atom has 4 valency electrons, that is 2, 4. In the outermost shell, how many electrons? 4 valency electrons. These 4 electrons are shared with 4 atoms of hydrogen to achieve a stable electronic configuration, that is octet rule, by sharing a pair of electrons. So when you see this diagram, you can able to understand carbon atom as what 4 electrons in the outermost shell, and hydrogen atoms, each atom has 1 electrons in the outermost shell. So when these hydrogen atom sharing 1 electrons to carbon atoms, what it form as a what? Methane molecule, and completely what? It completed the stable electronic configuration. So this is the formation of covalent bond in methane molecule. Next illustration is that formation of oxygen molecule, that is O2. Oxygen molecule is formed by two oxygen atoms. Each oxygen atom has 6 valency electrons, that is in the outermost shell, how many electrons? 6 valency electrons. These two atoms achieve a stable electronic configuration by sharing two pair of electrons. Hence, a double bond is formed in between the two atoms. When you see this oxygen atoms, in the first atom 6 valency electrons is there, in another atom also 6 electrons is there. Okay, so when these two atoms combining together, it's sharing a 2 electrons. Okay, and then it completed the what? Stable electronic configuration. That means that it completes the octet rule. Okay, so these two atoms share 2 electrons, so that it is called what? Two shared electron pairs. Okay, so now the oxygen molecule, first atom, it has electronic configuration 2 8, and next also 2 8. So here there is a what? Double bond is formed. Why? Because these two atoms sharing a 2 electron pairs, that is called what? Double bond. Next illustration is the formation of nitrogen molecule, that is N2. Here nitrogen molecule is formed by two nitrogen atoms. Okay, in the outermost shell totally 5 electrons. In the two atom 5 electrons in the outermost shell. So these two atoms achieve a stable completely filled electronic configuration, it must share what? 3 pair of electrons. Okay, hence a triple bond is formed in between the two atoms. Let's see the image. In the outermost shell, totally 5 electrons is there in both the atom. So, when these two atoms sharing 3 electrons, it completely what? It completing the stable electronic configuration. So, here each nitrogen atom sharing a 3 electrons, so that 3 shared electron pairs, and here what? Triple bond is forming. So nitrogen triple bond, that is it represents 3 line. Okay, yeah, 3 line in between this two nitrogen atom. Okay, so this is called the formation of covalent bond in nitrogen molecule. Now let's see the characteristics of covalent compounds. First is physical state. Depending on force of attraction between covalent molecules, the bond may be weaker or stronger. Thus, covalent compounds exist in gaseous, liquid, and solid form. Example, oxygen is a gaseous and water liquid, diamond is a solid state. Electrical conductivity. Covalent compounds do not contain charged particles, ions, so they are bad conductors of electricity. Melting point. Except few covalent compounds, diamond, silicon, carbide, they have relatively low melting points compared to ionic compounds. Solubility. Covalent compounds are ready to soluble in nonpolar solvent like benzene, carbon tetrachloride that is C6H6, CCl4. They are insoluble in nonpolar solvents like water. Hardness and brittleness. Covalent compounds are neither hard nor brittle, but they are soft and waxy. Reactions. Covalent compounds undergo molecular reactions in solutions and these reactions are slow. As we know, a metal combines with a non-metal through ionic bond. The compounds so formed are called ionic compounds. A compound is said to be ionic when the charge of the cation and anion are completely separated. Fajan's rule predicts whether a chemical bond will be covalent or ionic. Few ionic bonds have partial covalent characteristics which were first discussed by Kazimierz Fajans in 1923. In the time, with the help of X-ray crystallography, he was able to predict ionic or covalent bonding with the attributes like ionic and atomic radius. Fajan's rules are formulated by considering the charge of the cation and the relative size of the cation and anion. When the size of the cation is small, you know that what is cation and anion. When the electrons, which atoms loses electrons, it forms as a what cation, and which atoms gains the electrons, it forms as a what anion. So, when the size of the cation is small and that of anion is large, the bond is of more covalent character. Greater the charge of the cation, greater will be the covalent character. For example, in sodium chloride, low positive charge +1, a fairly large cation, and relatively small anion make the charges to separate completely, so it is ionic. In aluminum tetride, higher is the positive charge +3, larger is the anion, and thus no complete charge separation, so is covalent. The following picture depicts the relative charge separation of ionic compound, that is sodium N plus and magnesium Mg2 plus, Al aluminium 3 plus. It is lower positive charge. So in the ionic it has these conditions: 1. Low positive charge, larger cation, small anion. So you know that what is cation anion? The atoms lose electrons in the outermost shell. That is what form as a cation. One atom gains the electrons from the other atom. That is what anion. But in the covalent, higher positive charge, small cation, large anion. These are the relative charge separation of ionic compounds. Now we'll move to the coordinate covalent bond. In some compounds, the formation of a covalent bond between two atoms takes place by the sharing of two electrons, both of which comes from only one of the combining atoms. This bond is called coordinate covalent bond or also called as dative bond. For example, NH4 plus, that is ammonium ion, NH3 ammonia, in between boron trifluoride, okay, that is BF3. Okay, here in between ammonia and boron trifluoride forms a coordinate covalent bond. This arrow mark is represented by a coordinate covalent bond. The atom which provides the electron pair is called what? Donor atom. Okay, so the atom which provides the electron pair is called donor atom, while the atom at which accepts the electron pair is called what? Acceptor atom. So this coordinate covalent bond is represented by an arrow which points from the donor to the acceptor atom. Now let's see the formation of coordinate covalent bond. Let us consider two atoms A and B. Let atom A as an unshared lone pair of electrons. So one lone pair contains two electrons. And atom B is short of two electrons. So B has 6 electrons, but it needs 2 more electrons to complete the octet rule. Now atom A donates its lone pair while atom B accepts it. So this A is donates a lone pair to the atom B. So A is donating donor and B is what? Acceptor. Okay. So thus the lone pair of electrons originally belongs to atom A, or now shared by both the atoms, and the bond formed by this mutual sharing is called coordinate covalent bond. This arrow mark is represented the coordinate covalent bond. Next formation is that coordinate covalent bond in between ammonia molecule NH3 and boron trifluoride molecule. Here the molecule of ammonia NH3 gives a lone pair of electrons to boron trifluoride BF3 molecule, which is electron deficient, which that boron trifluoride. Thus a coordinate covalent bond is formed in between NH3, that is donor molecule, and BF4, that is acceptor molecule. So why ammonia molecule is the donor means it's sharing the one pair of electrons to the boron trifluoride. So boron trifluoride is the acceptor and ammonia molecule is the what? Donator. So this arrow mark is represented is what? Coordinate covalent bond. NH3 arrow mark, that is what? Coordinate covalent bond boron trifluoride, that is BF3. Let's see the characteristics of coordinate covalent bond. This compound contains coordinate covalent bonds or called coordinate compounds. Its physical state: these compounds exist as gaseous, liquids, and solids. Electrical conductivity: like covalent compounds, coordinate compounds also do not contain charged particles, ions. So they are bad conductors of electricity. Melting point: these compounds have melting and boiling points higher than those of purely covalent compounds but lower than those of purely ionic compounds. Solubility: it is insoluble in polar solvents like water but are soluble in non-polar solvents like benzene, CCl4 and toluene. Reactions: coordinate covalent compounds undergoes molecular reaction which are slow. Now the topic is oxidation, reduction and redox reactions. When an apple is cut and left for some time, its surface turns brown. Similarly, iron balls and nuts in the metallic structures get rusted. Do you know why these are happening? It is because of a reaction called oxidation. Let's see what is oxidation. The chemical reaction which involves addition of oxygen or removal of hydrogen or loss of electrons is called oxidation. For example, magnesium. Magnesium is combined with oxygen and form as a what? Magnesium oxide. Okay, so here addition of oxygen 2 Mg plus O2 gives 2 MgO. Here addition of oxygen. Next one is what? Calcium hydride. In this calcium hydride, hydrogen is what? Removed from the calcium hydride. So here the removal of hydrogen. Okay, next is Fe2 plus ion. Okay, here in the Fe2 plus they removed electrons. It is the loss of electrons and form as a what? Fe3 plus. So addition of oxygen, removal of hydrogen and loss of electrons is called what? Oxidation. Next is what? Reduction. The chemical reaction which involves addition of hydrogen or removal of oxygen or gain of electrons is called reduction. For example, sodium is combined with hydrogen and form as a sodium hydride. Here the addition of hydrogen, sodium is added with what? Hydrogen. So it combines and gives sodium hydride. So it is addition of hydrogen. Next is copper oxide. Copper oxide is added with hydrogen, but here in the copper oxide oxygen is removed and form as a what? H2O, that is water. So here removal of oxygen. This reaction is also called as redox reaction. So this is what? Removal of oxygen. Okay, next is Fe3 plus electrons. Okay, here also it is the gain of electrons. Okay, Fe3 plus electrons. It is a gain of electrons. So Fe2 plus. Next is redox reactions. Generally, the oxidation and reduction occurs in the same reactions simultaneously. If one reactant gets oxidized, the other gets reduced. Such reactions are called oxidation reduction reactions or redox reaction. For example, lead oxide is combined with carbon and gives lead and what? Carbon dioxide. Here there is a what? Removal of oxygen in the lead and addition of oxygen in the carbon. So these two is happening simultaneously. Oxidation, reduction. So this process is called redox reaction. In the second example, zinc is combined with copper sulfate and gives copper plus what? Zinc sulfate. Here also addition and removal of oxidation is happening. So these also called as what? Redox reaction. So what is oxidation? Addition of oxygen, removal of hydrogen, loss of electron. Reduction, removal of oxygen, addition of hydrogen, gain of electrons. Now, oxidizing agents and reducing agents. Substances which have the ability to oxidize other substances are called oxidizing agents. These are also called as electron acceptors because they remove electrons from other substances. For example, H2O2, hydrogen peroxide. Next is permanganate ion. Next, chromium oxide, dichromate ion. These are what? Oxidizing agent, and these also called as electron acceptors because they remove electrons from other substances. Substances which have the ability to reduce other substances are called reducing agents. For example, NaBH4, LiAlH4 and metals like palladium, platinum. These are also called as electron donor because they donate electrons to other substances. So these are called as reducing agents. Now, oxidation reactions in daily life. In nature, the oxygen present in atmospheric air oxidizes many things starting from metals to living tissues. For example, the shining surface of metals, tarnishes due to the formation of respective metal oxides on their surfaces. This is called what? Corrosion. And then the freshly cut surfaces of vegetables and fruits turns brown after some time because of the oxidation of organic compounds present in them. And next example is that oxidation reaction in food materials that were left open for a long period is responsible for spoiling of food. This is called rancidity. What is oxidation number? Oxidation number of an element is defined as the total number of electrons that an atom either gains or loses in order to form a chemical bond with another atom. Oxidation number is also called oxidation state. Let's see some of the example of oxidation number of the element. Oxidation number of potassium is +1, bromine is -1 respectively. Oxidation number of nitrogen in ammonia molecule is -3. Oxidation number of hydrogen is +1. Oxidation number of oxygen in most cases is what? -2. Oxidation number of neutral molecules is always what? 0. Let us find out the oxidation number of hydrogen and oxygen in H2O molecule, that is water. Let us take oxidation number of hydrogen. We already know that +1 is the oxidation number of hydrogen, and oxidation number of oxygen is -2. So now total number of electrons in the hydrogen is 2, and product of what? Oxidation number of hydrogen. What is the oxidation of hydrogen? +1, and plus total number of electrons in the oxygen and product of what? Oxidation number of oxygen, that is -2. So 2 into +1 will get 2, and 1 into -2 will get -2. So +2 plus -2 will get what? 0. Thus oxidation number of hydrogen is +1 and oxidation number of oxygen is -2. Children, go through all the topics once again. Thank you.